So, a mixed number is a mix of a whole number and a fraction. I didn't come up with that little reminder memory trick. I read it somewhere. I was oh, that's kind of a good way to remember it. So if they ask for a mixed number, then it's going to mix a whole number and a fraction part. So if I have 2 1/2, that means I'm talking about all of 2 of them and half of a third. Whereas an improper fraction is when my numerator is bigger than my denominator, so therefore it actually, I have more pieces than I have places for them if I was going to try to put it back in the pie pan or something like that. So it's improper, it just won't fit, overflowing. So an improper fraction is a fraction in which the numerator is greater than or equal to, so it actually could fit in the pie pan, I suppose, the denominator. What it's saying is it could be rewritten as a whole number or as a mixed number. So if I have 5 halves, it visually represents the same amount. So I have 1, 2, 3, 4, 5 halves. So we're going to talk about the long way of thinking about how a mixed number changes to an improper fraction, but then we're going to do a shortcut method so that we can play a bingo game and get through these numbers pretty quickly. So a mixed number can be changed to an improper fraction by converting the whole number portion to a fraction with the same denominator as the fractional portion. So basically, if I had 2, I would say, well, how many thirds is that? Each one of those 2 is 3/3, so I have 6/3, that sort of idea. And then adding the 2 fractions. So I could break this 4 3/5 into 4/1 3/5 so that I can make this into how many fifths would I have. So this is making equivalent fractions. So I have 20/5 for the 4 that I initially started with, but plus I still have the 3/5 that they gave me as the fraction part of the mixed number. Altogether I have 23/5. So that's the long method of showing like the whole number becomes this many fractions and then I add them together and I get this. We're not actually usually going to show it out that way. So the shortcut method to change a mixed number into its equivalent improper fraction, step 1 is to multiply the denominator by the whole number. So up in this previous example, that would be the 4 times 5, or the 5 times 4. That's telling me how many pieces that whole number is worth. It's worth 20 pieces if I'm breaking them up into fifths. Step 2 is going to be to add the numerator of the fraction to the product from step 1. So I know that 5 times 4 gave me 20 pieces, and I still had 3 pieces from my original number. So now I have 23 pieces. And then put the sum from that step 2 over the original denominator. Because you have to indicate what size pieces we're talking about. Question in the back.
When it says add the 20 and 5/5 and the 3 and 5/5, why wouldn't it be 23 over 10?
Because I'm have fifths. My 4, so shortcut or the long way, my 4, if I'm taking 4 pizzas or 4 pies or whatever, and I'm breaking each one of those into fifths, I have 4 that each have 5/5 in it. That's 25ths. Yep. So now I have 25ths because of the 4, plus the 3/5 they already gave me as part of that mixed number. Does that make more sense? So. No? So let's try it out. 6 2/3. The shortcut method, you don't have to show it all broken out. You do 6 times 3. You can tell what 6 times 3 is. Yes, ma'am. 18. Plus the 2 that I had already.
20.
Now I'm up to 20, but what size pieces are we talking about? Thirds. So 20 thirds. So again, I do 6 times 3 or 3 times 6, and that tells me I have 18 thirds or 18 pieces in the 6 holes, plus the 2 that I had already gives me 20 pieces, and those pieces are the size of thirds. The next one, 10 and 1/5. Go ahead and try it out on your own. This times that, plus that, and what size pieces are we talking about? What did you get?
51/5.
51 fifths, 51/5. Remember, the logic is 5 times 10 means 10 is the same as 50 fifths, plus the 1/5 at the beginning, 51 fifths. And the last one, 3 and 3/8. Da-da-da, da-da-da-da, da-da-da-da-da. What do you get?
27/8.
27/8. So you like the shortcut? I like when I don't have to show the work, but do you understand why the shortcut works?
Yeah. Yes.
All right, shortcut works because the 3 times 8 tells me that 3 cut up into 8s would give me 24 pieces, plus the 3 pieces I started with, 27, and the pieces are 8s. Make sense? All right, I'm going to clear the ink and scroll it so we can go the other way. The other way is even easier because you've already been doing it this year. It's just division. So an improper fraction can be changed to its equivalent whole number or mixed number by dividing the numerator by the denominator. But we've already done things where we might take 125 divided by 4 and make a mixed number answer. That's all it is. But the reason is, I'm saying how many 4/4 can I take out of there? Or in the first one, how many 3/3 can I take out of there? So for 5/3, how many 3/3 can I take out of there? What's going to be the whole number part of my answer? So how many 3/3 are in 5/3? 1. And then how many thirds are still left over? If I took out 3/3 to give me the 1, how many thirds is still left over?
2.
2/3. For the next one, I have 125/4. We want to know how many 4/4 we can take out of there. I personally know there's a good chance I'm going to make a mistake if I try to do it in my head. So go ahead on your notes, show the long division for dividing 4 into 125 and getting a mixed number answer. So you go ahead and do it on yours. I'm going to try to do it on mine. Except I have to get in my own way with the shadow here. Who thinks they know what mixed number? If I wiggle, you won't be able to see it. See? I'll move it.
I can kind of see it.
Almost. Who knows what mixed number is equivalent to 125/4? You man with the black shirt, jingle ball. Woo!
Wait, so should I say the answer?
Okay.
31 and 1/4.
31, and then the 1/4 is left over. I have 1 out of 4 to the next amount. So I'm able to pull out 31 4/4, and I still have 1/4 left over. Go ahead, try the next one. 27/8, how many 8/8 can you take out of there? That's your whole number part. And how many 8s are left? That's going to be your fraction part. What do you get over there?
3 and 3/8.
3 and 3/8. I actually just used the same number as before. I was feeling lazy, all right? Couldn't come up with any more examples. So while I go ahead and save this recording, you fill out the bingo board on the back side.